So how do you actually build something that can handle explosive growth? I mean, going from just a few users to a billion, it's one of the biggest challenges out there. The real question is, how do you pull it off without the whole thing just crashing and burning? Well, let's break it down.
Think about it this way. Building a shed? Pretty simple, right? You get some wood, a few tools, and you're pretty much good to go. But a skyscraper? Whoa, that's a whole different ballgame. You need a super deep foundation, a steel skeleton, a detailed architectural blueprint, and it's exactly the same in the digital world. That initial design, your architecture, that's what decides if your project becomes a landmark or just collapses under its own weight. To make this all feel a bit more real, we're going to follow the journey of a fictional app. Let's call it PhotoHive. It starts out as just a simple little photo sharing app, and its journey from this tiny project to a massive global service is going to show us exactly what it takes to build for scale.
Okay, so PhotoHive launches and boom, it's an immediate hit. People absolutely love it. But here's the thing about that first taste of success. It brings a challenge that can literally make or break any new service.
Get this, 100,000 users sign up in the very first week. The app goes viral. But the problem is, the entire thing, the website, the database, the whole shebang is running on just one simple server. And it just can't handle the load. The site gets slow, pages start timing out, and then it crashes.
So this is it. This is the first huge decision point for the PhotoHive team. The crazy thing is, their own success is breaking their system. This isn't just a technical problem anymore. It's about survival. What do you do when you have way more demand than you were ever built to handle?
To solve their problem, the team needs to scale their system. Basically, they just need to increase its capacity. And they're facing two fundamental choices on how to do that.
So their first option is to scale up. Think of this like taking your single server and just making it an absolute powerhouse. More memory, faster CPU, the works. The other option is to scale out. So instead of one giant server, you add a whole bunch of smaller ones and just have them share the workload. And this table really lays out the core trade-off. Scaling up is, simpler to manage at first, but it gets really expensive. And eventually, you just hit a hard physical limit. You can only buy so big of a server. Scaling out, on the other hand, is a bit more complex to set up, but it gives you almost limitless flexibility to grow. PhotoHive makes the smart call and chooses to scale out, adding a whole fleet of new servers. But this creates a brand new problem. When a user tries to go to photohive.com, which one of the dozens of servers should they be sent to? How do you even distribute all that traffic?
The answer is a supercritical piece of tech called a load balancer. It's basically a digital traffic cop that sits right out in front of all the servers. Its one and only job is to direct all the incoming requests and to do it efficiently and intelligently.
And here's how it works. A user's request comes in, and it hits the load balancer first. The balancer quickly checks which of its servers are healthy and have the least work to do, and then it forwards the request to the best one. This is what prevents any single server from getting overloaded, and it makes sure the experience is smooth for everybody.
Okay, so now the traffic is managed and the app is stable. Awesome. But a new complaint starts to pop up. Users in Europe and Asia are saying PhotoHive is slow. And that makes sense because all the servers are in North America, and that physical distance creates a delay. We call that latency.
The secret to making the app feel fast for everyone, everywhere, is something called caching. It's kind of like how a library keeps the most popular books right at the front desk instead of way back in the archives. By storing copies of popular data, like the most viewed photos, in a place that's super easy to reach, you can access them almost instantly.
And there are a few layers to this. You can cache data right inside the application itself, or you can cache results from the database. But for a global audience, the most powerful tool is a Content Delivery Network, or CDN. This is basically a network of servers spread all over the world that store copies of your content. So a user in Tokyo gets their photo from a server in Tokyo, not from one all the way over in Texas. It's a game changer.
So at this point, PhotoHive is fast, it's stable, and it's global. But all of this activity is creating one massive single point of failure, the database. Every new photo, every like, every single comment has to be written to one central database, and it is really straining under all that pressure.
Yep, you've got to scale the database too. And honestly, this is one of the hardest problems in system architecture. Some common techniques are creating read replicas, which are just read-only copies to handle things like searches, or sharding, which literally splits the database into smaller, more manageable pieces. Another path is to use entirely different types of databases, like NoSQL, which are designed from the ground up for exactly this kind of massive scale.
And all of this, all these problems and solutions, they lead to the single most important lesson from PhotoHive's journey. It's really the core philosophy behind building anything for massive scale. And here it is. This is the key takeaway. There is no single best architecture. It just doesn't exist. Every decision we saw the PhotoHive team make, scaling up versus scaling out, how they manage their database, it was never about finding a perfect answer. It was always about navigating trade-offs.
I mean, think about it. Do you spend more money to get better performance? Do you sacrifice just a tiny bit of data consistency to make absolutely sure your service is always available? Do you choose a simple design that's easy to manage right now, or a more complex one that you know can scale to 1 billion users later? These are the real, tough questions architects have to face every single day.
And that leaves us with the ultimate question. Building systems that can actually grow isn't just about writing code, it's about the choices you make. So for anyone out there building the next big thing, the real question isn't if you'll make a trade-off, but what you'll trade for scale.